This is TechSNAP, episode 424, for March 6th, 2020. Hello and welcome to TechSNAP, Jupiter Broadcasting Systems, Network, and Administration podcast. My name is Wes, and I'm joined by Jim.
Hi, everybody.
Let's start things off today with an update to a story we first talked about in episode 413. And that's the somewhat controversial rollout of DNS over HTTPS, or DoH. When we first started talking about DNS over HTTPS, it was still somewhat experimental. But that looks to be changing as Mozilla rolls it out as a default in the US.
Yeah, Wes. Now, to be clear, if you go into your Firefox options right now looking for DNS over HTTPS, you'll probably see that it's not enabled if you haven't specifically enabled it yet, because that rollout has only begun. It'll be taking place over the next few weeks in the United States. The other thing is you may have some difficulty figuring out where that is if you start from Mozilla's blog on the rollout, because they talk about some menu options that kind of don't exist. On a Linux machine, you would go to the hamburger menu and then go to Preferences. And on a Windows machine, you would go to Hamburger and then Options. Now, from there, either way, the easiest way to find it is just type DNS into the Preferences or Options search box. From there, you'll come up with network settings in the search box. And if you scroll down to the bottom, the very last option, which will be unchecked unless you've turned it on already, is Enable DNS over HTTPS. And we should also talk about who that DNS over HTTPS actually goes out to. Cloudflare is the default provider, but you can also choose NextDNS or Custom. And if I recall correctly, if you've already set your DNS provider in your resolve.conf on Linux or your network settings on Windows to somebody that supports DNS over HTTPS, it will stick with them. It won't actually change it by default in Firefox's settings.
And when that new default makes it to your machine, if you're based in the US, there'll also be a little notification prompt asking if you'd like to opt out. Now, I know it's not as good as opt-in for the skeptics out there, but to my eye, it really does seem like Mozilla is doing their best to attempt to ameliorate some of the concerns that folks have around this. It's easy to disable, you can configure it in the Firefox settings, and they do their best to detect when Firefox is deployed in a more managed environment like a corporate office, and disable it there as well.
Even for people who are going to get really paranoid about somebody being able to see the contents of their DNS queries and so forth, it's worth noting that Mozilla's not getting those. Cloudflare is, and Cloudflare is not getting any individually identifiable information. They're just getting DNS requests. It's pretty much all just going to kind of come in as a big blur. They can probably tie that to individual IP addresses, but again, that's just not really good for as much as people tend to think it is.
And as part of being included in Firefox's rollout, Cloudflare has had to sign on to their Trusted Recursive Resolver program, which is a legally binding contract that you can go look at and see all the rules and restrictions around what Cloudflare is allowed to do with all this data that's suddenly pouring in. And at least to my eyes, it seems pretty legit.
I would agree. For those of you who have forgotten or haven't looked into it so deeply yet, a quick reminder, DNS over HTTPS is mostly notable because it helps prevent your DNS requests from being hijacked by a local network. Normally, your DNS requests are just in the clear. They're not encrypted, and that means that any man in the middle could easily intercept them and give you responses that you don't want to receive and potentially lead you to the wrong network. Making those requests over HTTPS means that a man in the middle can't just tell you that Microsoft.com is actually at the same IP address as shadysite.ru.
And that is a big improvement. I mean, with the large rollout of SSL on the internet, we sort of got used to encryption by default, and really the DNS system is kind of the laggard in this respect.
Absolutely. And, at this point, probably DNS requests are the last thing that I really feel like I need to bring a VPN up, if I'm walking into a coffee shop or, maybe Black Hat or wherever.
Yeah, that is a great point. And sadly, there are still many parts of the world that employ DNS-based filtering. And hopefully with these easy Firefox options, that can be something we all just forget about.
Unless that country just blocks anybody that provides DNS over HTTPS, of course.
I'm just glad there's one less reason to have to fire up OpenVPN. Well, speaking of internet encryption, one of our favorite services just hit a major milestone.
And that would be Let's Encrypt, who issued their billionth with a B certificate this week.
Did you say billion?
1 billion TLS certificates.
For some perspective, their blog post notes that today, 81% of page loads globally use HTTPS, and that's at 91% in the United States. But way back in 2015, it was a very different story.
Yeah, in late 2015, when Let's Encrypt first launched, the encryption rate in the United States was 38%. So only 38% of page loads were HTTPS rather than HTTP. Now, in Let's Encrypt's first 2 years, they issued their 10 millionth certificate in 2017 in June. And at that point, 64% of United States page loads were HTTPS. Now, this week, when they issued their billionth certificate, they got up to servicing 192 million total websites, and the United States' portion of the internet is 91% encrypted. So in 4 short years, we went from 38% to 91%. Now, we probably can't lay the entire reason for that at Let's Encrypt's door, but I think they get out an awful lot of the credit, Wes.
Yeah, absolutely. It strikes me we often talk about the sort of balance between ease of use and security in technology, but here, Let's Encrypt found a way to make security easy, and that means the barrier to entry is just so low. These days, you can even find web servers with support for automatic provisioning of certificates through Let's Encrypt built right in. And I think that's really possible because Let's Encrypt started approaching things differently. And that new approach, it started with automation and Acme.
Absolutely. I wasn't really excited about Let's Encrypt when they first launched because all everybody really talked about was, money. Oh, these are going to be free certificates. And I'm like, certificates are down to under $20 a year now if you price shop. I get some people might care that, manage hundreds of them, but it's not enough to get me interested. They had been around for probably a couple of years before I realized for the first time, oh, wait a minute. You mean if I go Let's Encrypt, I can just install CertBot and have my certificates automatically deployed, automatically renewed, automatically everything, and I don't ever have to touch it versus, remembering once every year or 2 years to go spend a couple of hours, typically real time, between put in your credit card and request the certificate and fill out the form and wait for the people to sign off on it and click another couple of emails. And then, finally get the actual certificate you can manually download and manually copy to your web server and manually update your configs and finally have the fresh cert. All of this stuff, something that, if you only manage a few of these, you probably only do it every few months or even maybe every year or two. So it's never really that comfortable a process.
And that's also true for larger organizations where it might be a brand new employee who has to deal with that process. Instead, Let's Encrypt took the approach that we're going to make this happen all the time. You have short-lived certificates, and that means organizationally, you need to get good at managing and keeping them up to date. Thankfully, there's also automation involved.
Yeah, Wes, it's not really so much that you're going to have to do it all the time as that it happens all the time. I mean, honestly, once you install CertBot, you're pretty much done. There's not a whole lot that you have to touch anymore. The installation is very easy. There's not any complex instructions to follow. Like on Ubuntu, say you're running Apache 2, you apt install certbot-apache, and you run certbot-apache, and it walks you through a text interface that just asks you some simple questions, automatically detects every website that you've got a vhost for on that server. It lets you pick which sites you want, and you can just say all of them, and it generates certificates for all of them, installs it on all of them for you, offers to automatically give you vhosts, not just for SSL, but also to convert your existing HTTP to redirect automatically to HTTPS. You don't have to say yes to it, but if you want to, you can literally just say, yes, do that, and it's done. After that, you've got all your certificates, you've got all your configs. A cron job has been installed that will automatically attempt to renew any certificate that has 30 days or less remaining before expiration. There's nothing left to do. It's that freaking easy.
I think it's brought about something of a philosophy change as well. Last month, Apple dropped the news that Safari is no longer going to accept certificates that are valid for more than 13 months. And since Acme eventually got standardized as an RFC, we've also seen providers start to adopt it. So even if you don't want to use Let's Encrypt, you now have a new automated protocol that you can use with a variety of providers. And that just seems like a win for everyone.
So, Wes, it's probably worth mentioning that this isn't the first time that the maximum validity period of SSL certificates has been shortened. It used to be 5 years. It was shortened to 3 several years ago. And last year, an attempt was made to shorten it to 1 year for everybody at the Certificate Authority Browser Forum. Ballot SC22 was an attempt to shorten the maximum validity to 1 year. It did not pass, but it's a pretty contentious issue. It's not like everybody just said, oh, hell no. The final tally was 20 opposed, 18 in favor, and 2 abstentions.
I think it's safe to say we'll continue to see the lifetimes that are acceptable edge downward in the future.
I think it seems fairly clear that the writing on the wall here is certificate validity times are going to get shorter and shorter, and in a few years, I think we're probably going to be to the point where everybody's certificate process pretty much has to be automated.
Another thing I would like to note before we finish up this topic is that Let's Encrypt also managed to build a sustainable funding model for a combination of an open source project and a free online service. There's no paid tier that you need if you want to get, more features for the service. And it's not sitting there burning out their developers. In fact, their staff has even grown a little bit over time. And I think that's worth appreciating because we've all come to rely on it, and we need good models for services that benefit the common good.
Hear, hear.
Well, let's move right along to a story with a little more drama. We've covered the new instantiation of Microsoft's Edge browser, this time based on Chromium. And while generally we felt pretty positive about this development, seems like there's some recent shade throwing going on about Google's behavior and some enticing bribes they may be placing at Edge users.
Yeah, Wes, I've seen a fair amount of this, FUD slinging that Google is taking big pot shots at Edge, and they're going to break Edge to keep Microsoft from stealing their customers and blah, blah, blah. And on the one hand, that's certainly something that we ought to watch out for, but I think it's very unfair to claim that it's happening now. It boils down to, there's a couple of places where you'll get a pop-up or, more accurately, just a floating div, not really a pop-up, that says that, for example, if you want to view Google Docs offline, you can only do that in the full Chrome, not in Edge, which, that's true. That's a thing. That's a Chrome feature. Of course, you can also just save the Google document if you want to work on it offline. But I don't know. I think it's wildly irresponsible to stir up that much crap with as little in the way of shady dealings as we've seen. The important story here is not Google taking pot shots at Edge. The important story here is, Microsoft engineers making pull requests on, the Chromium project, and Google engineers and Microsoft engineers cooperating openly and publicly and, in a friendly manner and coming up with a single common platform.
Yeah, you're absolutely right, Jim. And unfortunately, none of this is really news about Google. Already, there are too many sites that only work in Chrome, especially if you're a Firefox user. But that said, I am hopeful Edge will work out as a nice alternative for folks who want to leverage all the great tech in Chromium, but who are a little wary of Google. And in that vein, it looks like we've just had some good news about Edge on Linux.
Yeah, Wes, I took a look at the Microsoft Edge roadmap, and as of February 26th, Missy Q at Microsoft says that they are planning for Linux support to drop in the Canary channel in 5 weeks.
Hey, that is exciting. It still just surprises me a little deep down that I'm seeing Microsoft making a Chromium-based browser that they're talking about running on Linux.
I'm not used to it yet. I'm not even used, for that matter, to Microsoft having this level of interactivity with their developers. Microsoft 10 years ago, you were not going to see somebody with a nick Missy Q just kind of informally blogging about the things that were coming up in a major project. You would get nothing but completely corporate, polished and chopped, almost information-free stuff. You probably wouldn't see the old versions at all. All you would see is whatever is current. Now you can just kind of see week to week what an actual dev says about the things that they're doing. And it's not always perfect. It's not always polished. And it's because, you're actually communicating with real people directly. And that's pretty exciting to me to see in the Microsoft world.
Well, I've just bookmarked the Microsoft Edge Insider page, and I'll be refreshing pretty often to see when I can get that Linux build as soon as it's ready.
Wes, what would you have said 5 years ago if I had told you, you know what, Wes? You're going to be bookmarking the Microsoft Edge Insider blog.
Wow, I wouldn't think I'd still be the person I am today. I'm glad that they changed and not me.
True.
Jim, I've been hearing a lot of hubbub about the latest Wi-Fi vulnerability, this time known as Crook. And while I took a quick look, I thought, as our resident Wi-Fi wizard, you might be able to provide a little bit more information and let us know who needs to care.
The first thing is, are you using devices with Broadcom Wi-Fi chipsets? If you're into Apple stuff, you may very well be using something, iPads or iPhones with Broadcom. The older devices tend to have discrete Broadcom chipsets, but most new phones and tablets, they'll use Qualcomm Wi-Fi built into the system on chip. And Crook only applies to Broadcom chipsets. There are also some routers and access points. But what it all comes down to is if you have one of these affected chipsets and your manufacturer has not provided a patch for it, basically anybody that wants to, who is sufficiently technically advanced, can just read your stuff like it was in the clear. So should you care about it? I mean, yes, you should, but I kind of feel like probably the better takeaway is that you shouldn't ever really rely on WPA2 as being anything more than, kind of like that little courtesy latch on the door. Wi-Fi encryption is not a VPN, and it shouldn't be relied on as though it were a VPN. If you really want to make sure that nobody can sniff your traffic, you need to be running a VPN, not just running over bare Wi-Fi.
That is good advice. The basic issue in the Crook attack is that under the right circumstances, the vulnerable firmware zeroes out a session key that's used to encrypt transmitted packets. And after a deauth, usually instigated by an attacker, anything left in the transmit queue is sent out. Unfortunately, by that time, the key has been zeroed, and that means anything left in the queue is transmitted with an entirely zero encryption key, and is thus trivial to decrypt. If you'd like more technical details, we'll of course have a link to the paper in the show notes, and it is worth a read. There are some interesting connections to the previous crack attack.
Well, Wes, our next topic is truly epic. Cloudflare is shifting from Intel CPUs to AMD in their data centers.
Yeah, I found this story fascinating. Obviously, we've spent a fair bit of time talking about the latest generation of chips coming out of AMD, and, well, we've been pretty positive about a lot of the advantages. But at least for me, I've only played with a couple of these systems, so a lot of it was still in theory. But Cloudflare has written up some great blog posts really detailing how they analyzed what the next generation of their server builds would look like, and why, after that analysis, they had no choice but to choose AMD.
I think I've maybe had my hands on a few more Epyc systems than you have, and they are great, but it's worth noting that even somebody who works with, tens or hundreds of machines the way that I do, there's a lot of potential for just kind of being influenced by your own preferences or letting one particular feature of a CPU, whether that be the price or the performance or the power, just according to your own preferences, kind of way larger than it really ought to in a more neutral 20,000 foot overview of which CPU is actually the better choice. Cloudflare, at the scale that they operate, they don't really have that luxury. They really have to drill down to look at a CPU in its entirety. If it uses too much power, it's going to be a no-go. If it's not fast enough, it's going to be a no-go. For Cloudflare, arguably the least important part is the actual individual price of the CPU. Which is interesting here because until recently, price has usually been the factor that's driven people to choose AMD over Intel to begin with. But now, Intel just doesn't really have anything going for it other than AVX 512 if you're using a workload that can be optimized for that.
Some background context here. Cloudflare has an approach where instead of specialized dedicated servers, they really basically have one type of server that they deploy everywhere. And that means all of their applications run on that same server type. So it makes sense for them to invest heavily in figuring out how to optimize and make sure that that build is going to perform well enough for all of their needs. And when you think about the things they do, whether it be their serverless offering called Workers or just maintaining all the firewall and DDoS protections that they have, that's eaten up a lot of CPU time.
And Wes, where a smaller operator like myself might end up getting focused on the performance per dollar spent on the CPU, that's not really Cloudflare's metric. What Cloudflare is worried about is the performance per dollar it spends to run these things for years at a time. And where that can really come into a problem is that with the Intel builds they were using, with the Xeon 6162, they had these things in dual socket blades. So you've got blade servers and you've got two 300-watt CPUs for each individual blade. You're not going to be able to fill a rack 100% full with those things before you blow through the power cap. So you blow through the power cap, and even if the rack's only half full, you've got to actually lease another rack for the rest of it, and your operational costs go up tremendously. Now, when Cloudflare looked at going from Intel to AMD, they're comparing these dual socket 6162 Xeons to single socket Epyc 7642. Now, either way, you're talking about a total of 48 cores and 96 threads. You've gone from two 300-watt TDP sockets to a single 225-watt TDP socket on the AMD side. And just to add insult to injury, that single AMD socket at 225 watts outperforms the two sockets worth of 6162s.
I can't summarize that any better than Cloudflare does in their blog. So that's it. AMD wins.
There's just no other argument, Wes. I mean, I can't find any reason to choose the Intel build here. You're talking about going from CPUs that we can't actually be sure what they cost because you can't buy one. The Xeon 6162 is OEM only, and if you're not buying a tray of 1,000 of them, as far as I can tell, you're not buying them. At our best guess, the cost is probably going to be somewhere around $3,100 to $3,300 per CPU. With two CPUs per system, you're talking about a total CPU cost there somewhere in the like $6,200 to $6,500 range, maybe. Versus if you want to buy one of those AMD Epycs, you can just go right to Newegg and buy one, and it's going to cost you about $5,000.
Wow, that is quite the difference.
There's obviously more to the power than just TDP. Different vendors measure thermal design power differently. And thermal design power is also about heat generated, not about electrical power. So it's not exactly a one-to-one comparison with your power cap on a rack. With all that said, Cloudflare has actually done this migration now, and they have more direct real-world data about power consumption. And when you look at the full system power consumption, they got significantly more requests per second per watt out of the AMD systems. And that's despite the fact that the Intel systems were blade servers, and the AMD systems are just 1U pizza boxes, a full system per CPU in its own chassis, the whole nine. And Wes, the last thing I'm going to say about that is Intel has really got to get themselves in gear here because, that performance per watt, that really is going to be the key metric for just about anybody that's doing data center work. Now, that may not be requests per second per watt. It may be some other metric of performance per watt for other customers, but I feel like it's going to be a lot easier for AMD to start leaning on really interested OEMs to start building blade designs and bring their performance per watt down even further than it already is. So Intel, you got some work to do, folks.
They sure do. And that brings me to a little addendum I wanted to touch on here. As an advantage to switching things out to AMD, Cloudflare now gets to start playing with AMD's memory encryption options. We've talked about this a little bit before in the past, but from their results, it looks like they're able to have total memory encryption with less than a 1% performance hit. And on Intel hardware, that's not even possible.
Yeah, I have to correct you a little bit there, Wes. It's actually secure memory encryption, SME, on the AMD side. Total memory encryption is Intel's feature to do the same thing, which doesn't actually exist yet. With that said, Intel is planning on bringing total memory encryption and multi-key total memory encryption, which very, very closely resemble SME and AMD's other technology, SEV, for secure encrypted virtualization. But although Intel has contributed a lot of software work to the Linux kernel to support it, they still haven't produced a CPU that actually enables either feature. For now, with Intel CPUs, your only option for memory encryption is the Software Guard Extensions, SGX, which is a much more limited technology. I have had a few security people yell at me that it's supposed to address a much different problem space, but basically, in order to use SGX, you have to write applications specifically to use it, and there are very significant performance implications to doing so. Whereas the AMD style full memory encryption, we're just going to say that because it's not anybody's individual acronym. Full memory encryption, the way AMD does it, and presumably the way Intel will when they bring TME and MKTME online, has almost no performance impact, and it's super easy to use.
Yeah, that sounds a lot better, where I don't have to redesign my application or decide which things to keep in secure memory and which things to keep in regular memory.
And I do feel like it's worth pointing out, especially as we just gave kudos to Microsoft for stripping out some of the layers of PR garbage and letting their developers speak naturally directly to people. Intel is not doing the best job of that right now. I saw a presentation on the upcoming TME and MKTME features, and Intel is labeling these as innovations. I got to be clear, this is not an innovation. We're trying to catch up to AMD here.
And in that same vein, let's just thank Cloudflare for having these discussions out in the open. Companies go through these exercises all the time, but it's not all of them that are willing to publish such detailed blog posts about these inner workings of their operations. If you're curious about all the graphs and figures and comparisons, well, we'll have that linked over at techsnap.system/424. There, you'll also find our Extras feed, which contains one of my favorite shows on the network, Brunch with Brent. The ever-charming Brent sits down for long-form discussions with many people in the open source community, including Jim and myself. It's a great way to learn more about the people that make our community tick. You can find it at extras.show. That'll do it for this episode of TechSNAP, but if that's still not enough Jim for you, and really, how could it be, you can find him writing over at Ars Technica. He's also on Twitter. Jim, you're
at JRSSNet.
I'm there too. I'm at Wes Payne.
We'll see you in a couple weeks, everybody.